Well, now I'd like to go to Earl Hackett. A couple of weeks ago, Earl finished the 3D design work on his 50-foot girder bridge. Well, tonight he's going to build the girder bridge that he printed out and show us how it finally came out. By now, hopefully, you've been able to print yours out or have it printed out. And I hope that that went well for you. I hope that you enjoyed that part of the presentation and had an opportunity to learn a little bit about what 3D design really entails and what it's all about. So Earl, I will turn it to you, sir.
Assembly of one of these things is really not right, because when you print it, it's one piece. There isn't any assembly. You got the thing. So what I'm going to do is tonight, I want to go through some of the details of how you set this thing up in the printer. Setting them up, those supports that you have to be placed where they aren't going to interfere with things. I'm going to start off with a little PowerPoint thing I put together. This is I built this about 20 years ago. It's the Wilmington, Delaware station here, Pennsylvania. At the time, I was freelancing trains. I just built whatever I felt like building, and this is my hometown station, so I started working on it. And it took me about 3 months to put the drawings together. They were published in Mainline Modeler. And then it took me about a year to build the thing. And it came out all right. There's starting the installation and the layout. But eventually I decided I was going to go start modeling a prototype. And I chose a C&O because it's always been one of my favorite. They have some of my really nice locomotives that I like. So it went away to a guy up in Massachusetts. And it was done in what we call an old, it was on an XP machine with ashlar vellum. It was one of the very first 3D CAD systems that came out. There was no 3D printing at the time. And it was so limited, you couldn't do the 3D detail on the front. So all you could do is make lines to say, well, these are bricks and these are shingles, and you just had to put up with it. Well, sure has changed. This is the bridge, the way I printed it out. This is basically this is the default. I just let Schleicher just go do its thing, because it's really. You can see we have lots and lots of supports, and these supports are attached to the plate where the green thing. This is the metal plate attached to the metal plate where these green dots are, and they pull this thing up from the exposure frame. And as you can see, they're attached at various spots here. And once this is done, they go through what they call a slicing routine. And a slicing routine looks like this. This is what it's doing is slicing it into 0.02 of an inch thick layers. As it goes through these layers, it records each layer, and that's going to be an exposure frame. And that's what you're going to expose to make your 3D print. Here comes it comes to the very top of the bridge, and it's done. Okay. The problem you run into, go back over here. This is the frame just before you get to the bottom of the bridge. And as you can see, we have attachment points here and here. These are all the little attachment points that are going to pull that off of the FEP frame film. Is a fluoropolymer. These things don't stick very well to it, but you have to lift it. And when you lift it, resin flows underneath this film, and this film is only 0.02 of an inch thick. So it's very, very weak. And when you lift it, then the frame goes back down and it exposes it again. And this is the exposure you get the second on the next frame. This is the next image on that series. And as you can see, we've exposed it. That's the center plate, center reinforcing plate on the girder. When you lift that up, it's only 0.02 of an inch thick. So in the spots between the supports, it warps a little bit, it bends a little bit. And the problem, what it does, it doesn't really come out. And you can see here, I'm holding this just right in the light. You can see this, all the little spots that we're trying to hold it up. And it's a pretty ugly surface. It's really not at all presentable. That's the bottom of the bridge. And who cares? You can't see it. And that's the way I like to do it. I want to get that out of sight and out of mind. So if you wanted to have all surfaces reasonably clean, you could tell let the computer, let the program automatically align the model, automatically position it. And when it's positioned like this, the only spot that has a problem is one little point down here. Everything else is a pretty clean surface, except where these supports tie in. In many cases, if it's a smooth surface, you could just sand them off and they go away. But here you have a board and batten siding. You can't necessarily get in there to sand these off. And they could be in a really difficult spot. The other problem is if you still just do it automatically, here I've put 3 handcar sheds on a platen and say, okay, you go ahead, figure it out for me. And what it does, it tilts the whole doggone thing in a single piece. And so you have some of them way down here, some of them way up here. Tremendous waste of resin. So I tend to, I do all my alignments, setting up the alignments in the CAD system. And then, to tell you the truth, I very seldom tilt the thing. With the with the Elegoo printers, there's a very specific angle at which you can set the printer to eliminate even the horizontal lines of the lines you see between layers. They call it each layer has a tiny little line that shows up, but at 15 degrees on the Saturn and 15.13 degrees on the Mars, those lines are obliterated. You get smooth surfaces. I've never had bothered with that, but I know one fellow over in Jersey that really gets excited about that. So there's a couple ways you can set this thing up. This one I set up with so the supports are all on the bottom. And yes, all my surfaces here are going to be nice and clean. The only bad surfaces are going to be on the bottom. But getting these supports out of the interior of this thing was a nightmare. I had them braced, and I couldn't get them out. I had to go in here with a screwdriver and a big chisel and a hammer and drive these things out of here. I got them out eventually, but it was not a pretty sight. If you go the other way, here we're putting all these little pock marks on the surface of the roof, and on but I'm still on the back side of the doors, and on the floor here. But these are surfaces that you can sand off very easily, and they're going to be a tar paper roof. Sand this off and paint it gray, and you don't have a problem. So the point is, you want to think carefully about how you're going to position the model for these supports. That is one of the more thoughtful parts you have to go through. This is that tower I showed you last week under construction, or the finished tower. And you can see we have supports inside here. They were a nightmare getting them out of there. It was awful, but it came out really well. This is a better illustration of it. But all along this surface here, this is the top. The roof comes down and covers this up, not a problem. And the floor covers up all the pock marks on the supports down here. And windows are similar. I like to make separate window frames and window sashes because I like, just like with that fire station model, I like to have them partially opened in various configurations so that they it looks sort of like if it's a hot day in the summer, you want the windows open. They didn't have air conditioning back then. But in this case here, these are all printed, gang printed in a one print job. Phone booths. This is another thing that you need lots of, are telephone booths. If you're modeling in the 50s or earlier, you didn't have radio. And so they had these phone booths all over the place. It's the only way the engine crews could communicate with the tower operators. And I need a lot of them. Another example of, here's a couple of, these are the default positions for supports with the Lychee slicer. And I use two. One is the Lychee slicer and the other is the, I'll remember the name in a minute. But this one here, it's not quite as uniform. It's not quite, but it does a reasonable job. Things come out okay, especially on something like this, because these cross braces here are self-supporting to a large extent. You don't really have to put a lot of support on those. The horizontal braces, they do need support because, and it supplies support to them. If you go to the, this guy here, the shoe-box slicer, you can see it does a much more throws. This is the same part, but it goes crazy with its supports. And you get much more supports, many more supports all over the place in the case of the shoe-box. And you get more precise positioning of the components, but you get more little dings that you may have to remove. This is a Pogue water column that I built. This is the Lychee slicer version. And you can see down here, this is what they call bracing. They'll take adjacent columns and put diagonal bracing in between them. Makes for much stronger structure, but it also is much more difficult to remove if it's anything other than just a straight line like this, because the whole thing becomes one solid mass of support. This is the shoe-box version of it. Again, lots more bracing, and just more stuff to remove. But it does a better job of it. I like them both, and in this case, this was about as good as you're going to get. I just accepted this when I was doing my prints, and it worked fine. Okay. This is the roof. I'm going to do a little bit of discussion about CAD systems. The Onshape is really intended for mechanical mechanisms. If you're going to build a V8 engine, put all the parts together in Onshape, and you can run the thing, and you can make sure that all the parts move exactly where you want them to move. Then you can take all the parts apart, machine them, and build your engine. It's not optimum for building scale models. This one was a roof for that station. This is for the this is one I did for the station at Ronceverte, West Virginia. And you can see it has an angle here, comes down at one slope, and then it changes slope. And all these tiles here, this in my old XP machine, I couldn't have even attempted this because it didn't have the memory. The newer machines, memory is not a problem, and this is a close-up of the tiles. This is I guess it'd be an all asphalt tile roof. But on each tile, you have this surface here, you have a side here, here, and here, and then this little filler piece back in here, and you have a surface here. Each one of these pieces has 4 coordinates. Each coordinate has 3 points, 4 points defining it. Each point has 3 coordinates, X, Y, and Z. The memory requirements for building one of these things is huge. So you need a pretty high-powered machine to handle this kind of database. And fortunately today, machines are available that can do this that are not very expensive at all. Other things that I designed on this are with Rhino is this is a turntable drive, worm and gear inside here that I cast, metal parts that handle it, and it's a little different. I use a optical switch to control the polarity of the turntable tracks as it's spinning around, optical switch and a relay. This is a switch machine that I'm working on right now. I've torn my layout out. My layout is history, it's gone. I'm building a new one, and I'll show you why in a few moments. But I have a storage area, double-deck storage area that doesn't have room for switch machines hanging down below the upper deck. So they have to be off to the side with a long rod, push rod coming in. And so I've elected to use, this is the motor I have. These are motors from Micromark. They're switch tender motors. It's a gearhead motor, huge torque. Runs a double-threaded Acme, quarter-inch Acme screw here. All the other parts here will all be 3D printed. And it runs between 2 optical switches. It travels until it breaks this beam and then stops. And it will also rotate a switch stand, which will be illuminated. Little lamp up here, which is illuminated green and red or yellow and red, depending on whether it's a yard or a mainline switch. You can also do very fine work. This is my chair that I sit in when I'm working on my models. And that's the roll top desk that I'm sitting in right now. They're installed in the switch tower. And this is the bunkhouse at Thurman, West Virginia for overnight crews. And this will be the first building I have built for that layout. And this is why I particularly like Rhino. I can do all this stuff. All this is done in Rhino. I can make artwork for brass etchings. I can make artwork for decals. And the thing that I really liked about it was I can do my track plans on it. This is a Thurman, West Virginia. I scaled it down to HO scale and put it in Rhino. And then I went and put dots on every so often along the tracks here and said, okay, Rhino, give me a circle, an arc through those points. It gives you the best fit arc. And from that, I get the center of that arc and I can lay out my other tracks. And this is my basement. I have 36 feet and it just fits, including the bridge across the New River. I like to build things. That's what I really enjoy in the hobby. And this is something that I've always wanted to do, but it was impossible until I had a decent CAD system and the ability to do 3D printing. There'll be a few models like these 2 water tanks right here. Those are kits that I have. They're sitting down in the basement. But everything else, I have drawings for all the buildings, every one of these buildings, thanks to the C&O Historical Society and the National Park Service, except for the Lafayette Hotel and the Armour plant here. I have 4 photographs of these 2, and I'll work from those photographs to build them. But we'll be going down there in a couple of weeks, and I'll get exact measurements of the foundations that are still sitting there. So the thing about a CAD system is the interface. And I have a particular way I like to work. Everybody is a little bit different. I'm going to bring up I just want to show you what I work with. I'm going to go to new object, millimeters. This is the interface for Rhino. This is what I work in. I've been using it for I don't know how many years now. But let's just make a sphere just for the heck of it. Sphere center radius. Okay, there. View. Shaded. I want to see this one shaded too. And you can run this around. It has all the functionality that you saw in Onshape, but it also can do planar drawings, as I show with the etching artwork and the decal work and my layout. That's all just lines on a flat sheet, just on the top view. So this is my do everything system. You can do a surface like that. Now let's get this perspective. I don't know. See if that was flat. Oh yeah, that's flat. But let's go back to the four-way view. It also does very strange things. For example, let's do another surface. There, and here. I don't know what it is, but it can make it'll do very. It was designed for building ships and aircraft, so it does very exotic curved surfaces. I never use it, but I do find that it's useful for making rock walls. If you have a building with stone facing, you can make all the stones separate, and they're not copies. You can make a couple dozen stones, plop them down in random patterns, and it doesn't look like it's just a cookie cutter image. So this is just the way I like to work. It's not cheap. It's $1,000 for a permanent, but you only pay it once. It's a permanent license, and it's just what I like. There are other systems out there, and what you want to do is explore them, find one that you like, and go with that. So with that, I'm going to stop sharing. There we are. Thank you. So if anybody has any questions or about what CAD systems in general, I'm always available for helping. I've been doing it for a long time, and I'm looking forward to a new layout right now.
I hope you'll come back and show it to us as you get it built, and not just wait until it's finished, but show us pictures and show how you're doing as you move along.
Yep. Right now, I'm salvaging all the parts from the old layout, and that's going to make the platform all go very, very quickly. But what I'm really looking forward to is building that bridge. It's a girder bridge, not a girder bridge. It's a truss bridge, and it's quite a different truss bridge. So it all has to be scratch built, and that'll be all done on my printers.
Well, I look forward to seeing you when you get it done. And thanks so much for doing this, Earl. I think this has been very, very valuable for a lot of us to see really what's involved and how sophisticated the CAD design can come and be. And I do think it's part of the future of model building. And that's why I wanted somebody that's an expert in it to try to give us a flavor for what's involved and how to do it. So I can't thank you enough.
Oh, I was very pleased. I was very glad to do it. And what I'm doing is fairly complicated, but you start off with something simple like a little shed, and you work from there.
And like he said, you got any questions? You've got his email. He'll be glad to respond to you. Yep. So Earl, thanks again for doing this. I really do appreciate it.
You're welcome.